Hello friends, welcome to Learner's Planet. Friends, this is our second session for area and volume. In the previous session, we have discussed the basic terminologies related to rectangle, square and triangle. In this session, we'll be discussing some more terminologies related to other geometrical shapes. So let's begin the session. Now, let's discuss about a parallelogram. You can see a parallelogram over here. These are the sides. A, B, C, D are the vertices. A, B, B, C, C, D and D, A are sides. This AC and BD are diagonals. They bisect each other at the, suppose I tell this point at as O. So AC and BD bisect each other. Okay. Now, in the case of parallelogram, the opposite sides AB is parallel to CD and AB is equal to CD. Similarly, BC is parallel to CD and BC is equal to CD. Diagonals AC is not equal to BD, but they bisect each other. Okay. Now this angle and this angle, they will be same, and similarly this angle and this angle, they will be same. Okay, not necessarily to be 90 degree, but they will be same. Apart from that, sum of this angle plus this angle, this angle A plus angle B will be 180 degree, and similarly angle B plus angle C will be 180 degree, angle C plus angle D will be 180 degree, and angle D plus angle A will be 180 degree, and we call them its interior opposite angles. Okay, angle A plus angle B is 180 degree, and the similarly other four pairs we call them interior opposite angles. Okay, and why they are called interior opposite angles? Because these two angles are between these two parallel lines. Okay, these two parallel lines. Okay, so I hope you are clear about this, what interior opposite angle is. And similarly, the sum of all the four angles will be 360 degree since it is a quadrilateral, and we have already discussed that for any quadrilateral, sum of all the four angles will be 360 degree. Okay, now what is the perimeter? Definitely sum of lengths, that is AB plus BC plus CD plus DA. So we can say 2 times AB plus BC, because the length of AB will be equal to CD and the length of BC will be equal to AD. Okay. Now, if we talk about the area of a parallelogram, then it will be base into altitude. Here, the altitude is this. Suppose it is point P. So this is the length of altitude, that is CP. And base we can consider either CD or AB, because the length of AB and CD will be same. So area will be equal to base, that is AB, into altitude, that is CP. Okay, so if you know the length of AB and length of altitude, you can calculate the area of the parallelogram. Okay, now one more important thing over here, that various types of angles are formed between two parallel lines, and frequently questions are asked based on them. So I just like to make a quick recap over here. You might have studied this terminologies in your 9th-10th grade, but still I would like to make a recap. Okay, now this angle and this angle, both of these angles will be same and we call them as corresponding angles. Okay, I just name all the angles. It's A, B, here we can see the different labels. Now this angle OAB, this angle and this angle, both of them will be corresponding angles. Suppose I name them as angle 1 and angle 2. So angle 1 will be angle 2 equal to angle 2, and these are corresponding angles. Okay, so for two parallel lines, these two are the parallel lines and this is known as the transversal, that is intersecting both the lines. Okay, so various angles are formed. So we are discussing the relationship among them. Here angle 1 is equal to angle 2. These are corresponding angles. Similarly, suppose this is angle 3, this is angle 4, this is angle 5, this is angle 6, this is angle 7, this is angle 8. Okay, so angle 1 is equal to angle 2. Similarly, angle 6 is equal to angle 7. Further, these are both of these angles are on the same side of the parallel lines. So they will also be corresponding angles. Similarly, angle 5 is equal to angle 8. Both of them are corresponding angles, and angle 3 is equal to angle 4. Both of them are on the same side of the parallel lines. So even these are corresponding angles. So these four types of corresponding angles we are getting in this set. So all of them will be angle 1 will be equal to angle 2, angle 6 is equal to 7, angle 5 is equal to angle 8, angle 3 is equal to angle 4. Okay. Similarly, we have other type of angle, that is alternate angles. So whenever two parallel lines are there, something like this, and if a transversal is intersecting, we can see a shape of Z, something like this. Okay, or maybe like this. Okay, so this angle and this angle, both of them will be same, and we call them as alternate interior angles. So okay, so in this case, angle 1 will be equal to angle 4. Similarly, angle 6 will be equal to angle 4. This angle is equal to this angle. Similarly, we can see a shape of Z over here. So angle 5 will be equal to angle 2, and we call them as alternate interior angles. Okay. Now, apart from that, angle 2 plus angle 6 will be 180 degree. Angle 5 plus angle 4 will also be 180 degree, and these are interior opposite angles. So sum of interior opposite angles is always 180 degree. So we discussed three types of angles so far, that is corresponding angles, alternate angles, and interior opposite angles. One more pair is there, angle 1 plus angle 3, that to 180 degree, because this is a linear pair. Angle 1 plus angle 6 will also be 180 degree, that for the linear pair, because they are the angle formed on a single line. Okay, so this will also be 180 degree. And angle 1 is equal to angle 5. This is linear pair, and angle 1 is equal to angle 5, that is vertically opposite angles. Friends, will be discussing all these terminologies in much detail when we'll in our geometry sessions. But as of now, I'll be discussing the things which will be necessary for you to understand the problems and to solve the problems. Okay. So these are the basic things regarding a parallelogram and two parallel lines. Okay. Now, the other shape is rhombus. Now, similar to parallelogram, the all the opposite sides of rhombus are parallel to each other. But what is the difference between a rhombus and a parallelogram is that all the four sides of rhombus are equal. Okay, suppose this is A, B, C, D. So AB will be equal to BC, that is equal to CD is equal to AD. That means all the four sides of rhombus are equal. And these are the diagonal, that is BD and AC. Further, diagonals are not equal to each other, but they bisect each other, and they bisect each other at 90 degree. Okay, so this angle is 90 degree. That means we can say AC is perpendicular to BD. Okay, now suppose the length of diagonal is D1 and D2. So we can calculate the area of this particular rhombus. So I just explain you how to calculate that. So this is a right angle. Okay, and how we have already discussed discussed about the area of a right angle triangle. So that is half base into altitude. Okay, and we are having 4 such triangles. So let it be 4. Then this will be half of this diagonal, so half of D2, and this will be half of D1, that is the half length of the complete diagonal. So area of the triangle is half base into altitude. So this is the base, this is altitude, and this is half. So it's half d1 d2, that is the area of the rhombus. That means product of diagonals divided by 2 is the area of rhombus. And we have to be clear that there are 4 right angle triangles, okay, in a rhombus. And the perimeter is same, AD plus DC plus CB plus AB, or we can say 4 times side, because the side, all the sides of rhombus are same. Okay, I hope you are clear. Now the next is trapezium. Trapezium is also a type of quadrilateral having 4 sides. Here A, B, C, D. Now it is a type of quadrilateral where only one pair of opposite sides is parallel. Here AB is parallel to CD, but it's not necessary that they will be equal also. Okay, so AB is parallel to CD, but BC is not parallel to AD. Okay, so we have one pair of sides which are parallel to each other. Okay, now the perimeter will be AB plus BC plus CD plus DA, and let's calculate the area of trapezium. Here this is the altitude, or we can say distance between both the parallel lines. So this will be of 90 degree. So I suppose this distance is D. So the area of trapezium, it's sum of parallel sides, half sum of parallel sides, that is AB plus CD, into distance between them. So distance is D in this case. Okay, so half AB plus CD, that is sum of parallel sides into distance between them. So by this way you can calculate the area of a trapezium. Okay, the remaining things or the remaining properties of two parallel lines will be fulfilled in the case of trapezium also. Since AB is parallel to CD, so the remaining properties like alternate angles, corresponding angles will be fulfilled over here. Okay. Now let's discuss about circles. Friends, this is going to be very important topic. Okay. Now we can see a circle over here. This is the center of the circle, and from center of the circle, that is if we draw a line that is intersecting the boundary, this boundary, suppose at P. So this OP is radius of circle. Okay, so OP, or we can say it is OQ, it is OR, it is OS. Okay, so OP, OQ is equal to OR is equal to OS. All of these are radii of circle, and all of this will, for a single circle, radius will also be, radius will always be same. Okay, now double of radius is called as diameter. So here PR and QS are diameters. Okay, and this boundary, if we talk about PQRS, this boundary is known as circumference. Okay, and this is the center of the circle. Okay, so these are the basic terms related to a circle. Now let's calculate the circumference and area. I assume the radius of the circle is r. Okay. So circumference C will be 2 pi r. Here pi is a constant and the value of pi is sometimes taken 22 by 7 or sometimes it is approximately we take 3.14, and we have to take the value or we have to choose the value according to the data provided in the question. Okay. So it's either 22 by 7 or 3.14, and we have to be clear that pi is an irrational number. 3.14 is the approximate value of 22 by 7. Okay, though the value of pi is not exactly 22 by 7, it is 3.14 something something something. Since it is approximately equal, so we choose instead of 3.14 22 by 7. But be very clear that pi is basically an irrational number. Okay, now similarly, area of circle, suppose it is A, then it will be pi r square. Okay, so these two are the basic formula to find out the circumference and area of the circle. Now let's discuss the other terminologies also. Now we see this circle, this is center O, this is P Q, so this will be radius. OP will be equal to OQ. These will be radii of the circle. OP is equal to OQ is equal to R. Now we see a line PQ. Okay, so this length, if you just see this particular part of the circle, so this part of circumference, so this complete length is circumference. So the small part of the circumference, I suppose it is maybe x. So PXQ, this part is known as arc of the circle. Okay, PXQ, and we represent it as arc PQ. It's like this. Okay, so it's arc of circle. Okay, here suppose there is a point y. So PXQ is minor arc and PYQ will be major arc, because this is the major portion of the circumference and this is the minor portion of the circumference. So PQ is arc of the circle, and similarly this PQ is also arc of the circle, but it is PYQ. Okay, so this is minor arc and this is major arc. Okay, apart from that, there are segments of the circles. This particular portion which is white over here, so this particular portion is segment, and this portion which is the which is green over here, this is also segment. Now this is minor segment and this is the major segment. Okay, so we discussed about arc and we discussed about segment of a circle. Okay, now suppose we have to answer the question related to area of segments, then how would we approach? Just wait a moment. Now suppose we wish to calculate the area of this OPXQ. This is part of circle OPXQ. Since the center angle of a circle is 360 degree and this part is theta from 360 degree, so theta from 360 degree times pi r square will be area of this portion. Okay, so area of OPXQ will be theta by 360 into pi r square. And suppose if we wish to calculate the length of this arc, length of arc PXQ, further it will be dependent on this angle, so it is theta by 360 times 2 pi r. Okay, 2 pi r is the complete radius, so whatever this angle will be, so that will be the part of from 360, and 2 pi r is a complete radius, so 2 pi r into theta by 360 will be the length of this arc. Okay, now here we calculated the area of this complete part. So if we deduct the area of this triangle from this complete part, we'll be getting the area of this white part, right? Just see this complete part. Okay, if we deduct the area of this triangle, we will be getting the area of this part. Okay, so area of segment is equal to, see, we got this complete area, that is theta by 360 into pi r square, minus we deduct the area of this triangle, area of triangle OPQ. Okay, so whatever the radius is given to us, we can calculate the area of this triangle. We will be discussing this property in detail when we'll be solving the problems. So exactly at that time when we'll be having the data in our hand, the problem or the concept will be more clear. Okay. Friends, till now we have discussed about 2D shapes, that is the shapes which are having only two dimensions, and we discussed their areas, perimeters as well, okay, and the basic properties as well. Now we are going to take 3D shapes. 3D shapes, that means something can be filled into them, that is they have three directions, or we can say they have capacity. Okay, so here we see first of all a cube. Okay, now a cube is, we can say there are 6 faces. Okay, if you might have seen a dice with which you might have played this Ludo and snakes and ladders and all that. So that dice is actually cubical. Okay, so as far as cube is concerned, it is a combination of 6 square, or we can say it is a closed figure having 6 squares. Okay, like this. Okay, so this particular portion, I see this portion, this is a face of the cube. Okay, so this is, I just write it over here. This is face of the cube. These are vertices. Then this length, this length is h. Okay. Now, as I told you, there are 6 squares which are making this cube. Okay. So let's calculate the area and volume of a cube. Now, suppose the side of this particular square which I am showing over here is A. Okay, so since it is a square, all the 4 sides will be of same length. So area of one square will be A square, and we are having 6 such square. Okay, so 6 times A square, that is 6A square, that is the area of a cube. Okay, now suppose we have to find out the volume. For volume, always keep one thing in mind, that is its base area into height. Okay, now what is the base area? Since the base is also a square, so the base area will be A square, and height is, since it is a square shape, so height will also be A. So base area is A square and height is A. So the volume of the cube is A cube, or the unit will be cubic. Okay, we can say it is cubic centimeter or cubic meter or cubic inch, cubic foot, something like that. And the unit of area will be in square units. Meter square, centimeter square, square inch, something like that. Okay, now in various examinations the relationship among vertices, edge and faces are asked. Okay, so there is a formula for the same which shows the relationship among these three. I just write it over here. Wait a moment. It's number of faces plus number of vertices is equal to edges plus 2. So here faces are 6, vertices are 8. We can see 1, 2, 3, 4, 5, 6, 7 and the other one. Okay, so 6 plus 8. Edges will be 1, 2, 3, 4, similarly 5, 6, 7, 8, 9, and the other ones that we are not able to see, but you can visualize them. So they will be 12. So this is a relationship among faces, vertices and edges, and we call it as a Euler's formula. Okay, so if anything is unknown, you can find that out. Okay, you just can visualize the shape and you can find out the faces, vertices and edges. Okay, here I have mentioned about cube. Similarly, the vertices, edges and faces for a prism you can find out. Okay, so we discussed about the relationship, we discussed about area of a cuboid, of a cube, I'm sorry, and volume of a cube. Okay, now we see a new shape over here, that is cuboid. Okay, now it's made up of 6 rectangles. Okay, so this is a rectangle, this is further a rectangle, and this is further a rectangle. So three types of rectangles are there, and the opposite faces are same. Suppose the length of this rectangle is a, and the height, this particular thing is height, suppose it is h. I take length as l, height is h, and this is the breadth of this particular rectangle, so I take it as b. Okay, now since we are having 6 rectangles, we just try to find out the area of each rectangle. So in all, surface area of a cuboid. Okay, now what will be the area of this face? That is L into H, and the same area will be there of the opposite rectangle, that is the opposite face. So it will be further 2 times L into H. Plus similarly, area of this particular rectangle will be B into H, and this face and the face opposite over here, so it will be also 2 into B into H. Similarly, the third one is area of this length is L and this length is B, so area of this face will be L into B, and similarly we have 2 rectangles like this, so it will be 2L into B. So in all, surface area of a cuboid will be 2 times LH into BH into LB. Okay, now if we talk about volume, so base area into height. What is the base area? That is length into breadth, and height is h. So the volume of cuboid is length into breadth into height. I hope you are clear. Friends, I hope you might have enjoyed the session, and we have discussed good number of shapes in this session. In the next session, we will be taking the other 3D shapes like cylinder, we will be taking cones as well, and spheres also. And so do revise this session before coming to the next session. Bye bye.